All right. So today we are bringing back Bob and Pat, the two guys from last week who were going out to eat. And if you did not watch videos from last week, that's okay. You should still get what's going on. Okay, so this week Bob wanted to go out to eat, but he decided he was going to go by himself. He didn't care if anyone else came with. So when he went and got pizza again. So he ordered 3 slices of pizza, and he was real thirsty, no refillable drink, so he ordered 2 drinks. And his total was, let me think for a second, was $7. Okay, so he's eating his pizza, and sure enough, here comes Pat. He had the same idea. He wanted to eat by himself. So we went and talked to Bob, and Pat's like, gosh, I am starving and just so thirsty today. He decided to get 6 slices of pizza and 4 drinks. Any idea what his cost is going to be? Well, the two talked about it, and they got $14. How do you suppose they got 14? Well, if Bob went and ordered this same thing, so if he went and got 3 more pieces of pizza and 2 drinks, do you agree it would still be $7? Yes. But now, what if he would have ordered that all together? He would have had 6 slices of pizza and 4 drinks, and instead of $7, it would have been $14. So, what we did, so Pat's order is actually 2 times Bob's order. So what we did was we took his 3 slices of pizza, we doubled it. We took his 2 drinks, we doubled it. So that must mean that Bob's cost must be double or 2 times, or Pat's must be 2 times what Bob's was. So now, if we take that and we actually put it into some equations, so we had Bob had 3 pizzas and 2 drinks, and that cost was $17. So what you can do is you can take this equation, and let's say you had a whole family come in and they wanted to get 12 slices of pizza and 8 drinks. How much do you think that one would cost? Okay, so, oh shoot, sorry, I wrote this down wrong. This was just supposed to be 7, not 17. Anyway, so how much do you think this total cost is going to be? It should be $28. How did we get that? Well, we took 4 times this equation. So, let me erase that. In general, we can multiply any equation by any number. I should say we can multiply. Okay, so when you multiply any equation, it's both sides of the equation. And I'll show you an example here in a second. By any number, and the equation is still true. Okay, so let's look at an example. So let's say we have 5x minus 2y equals 6. So as long as I multiply both sides by the same number, the new equation is going to be true. So let's multiply it by 3. So multiply by 3. So we're going to write 3 times 5x minus 2y. We multiplied the left side by 3. And we have to multiply the right side by 3. So then we get 15x minus 6y equals 18. So this and this are exactly the same. So let's look at one more example. Let's do, actually, let's go back up here for a second. If, let's say I started with this one and I went to this one, how did we go from here to here? Instead of multiplying by 3, what did we do to both sides of this equation? We divided by 3. So you can also divide everything by the same number. But for this week, we're just really going to focus on multiplying and not so much dividing. Okay, so now back to our next example. So let's say again we have 5x minus 2y equals 6. This time we want to multiply by, let's do negative 4. So it doesn't matter what you multiply by as long as it's the same. It can be positive or negative. So when we write this, we're going to have negative 4 times the left side. So 5x minus 2y equals negative 4 times 6. Okay, you distribute the negative 4, so you get negative 20x. Negative times a negative is a positive, so that's plus 8y. And then equals negative 24. So this and this are exactly the same. So again, as long as you multiply both sides by the same number, the equations are going to stay true. So now you're probably wondering, why on earth would you ever want to multiply an equation just to get the same thing? Well, last week we looked at problems that had elimination. So when you are eliminating, remember you want to have a coefficient and a variable that are the same but with opposite signs. So here we have a negative 4 and a 2. Well, those aren't the same number. And here we have a negative 2 and a 4. Well, those aren't the same number. So in order to eliminate, we need to make either these two numbers the same with opposite signs or these two numbers the same with opposite signs. So you can pick X or Y. It does not matter which one you do. So just for this sake, let's just say we want to eliminate. Let's do X. Okay, so we have negative 4x and we have 2x. We want those two numbers to be the same. So we can either multiply the top equation or we can multiply the bottom equation. And we want the two numbers to be the same but with opposite signs. So what number can we multiply either the top or the bottom by so that way they're the same? Well, we can, a different colored pen somewhere. Maybe not. Okay, so we can multiply, if we multiply this bottom equation by 2. So if I take this side and I multiply it by 2, and I take this side and I multiply it by 2, because what you do to one side, you have to do the other. So now let's just rewrite these quick. Oh, I found my other pen. Okay, so if I'm going to rewrite these, I just have negative 4x minus 2y equals negative 12. Okay, then I'm going to rewrite this one, but now I'm multiplying the whole thing by 2. So we'll have 4x, 2 times 4y is 8y, equals negative 24. So now we have negative 4x and we have a positive 4x. So same numbers, different signs, so these will eliminate. Okay, so now instead of going through this whole problem, I just want to practice the multiplying part for now. Okay, so let's say we have this one. So again, you can eliminate either your x's or your y's. It does not matter which one. This time let's eliminate the y. So we want to eliminate y. All right, so now we're looking at a positive 1y. Don't forget there's just a 1 in front of here. 1y, and we have a negative 7y. So they're already different signs, but we need to make the numbers the same. So what can I multiply by so the numbers can be the same? Well, we can multiply this top equation by 7. So multiply the left side, multiply the right side, and if I rewrite those, so here we're going to distribute. So 7 times negative 5x is negative 35x. 7 times 1y is 7y equals 9 times 7 is 63. And then I just rewrite this bottom one. So you have 10x minus 7y equals negative 18. And now we have 7y and negative 7y, so these ones will eliminate. All right. How about this one? This time, let's eliminate the y's. Okay, so this time we have 1y again, and we have 3y, but they're both positive. So remember, when you eliminate, you want one to be positive and one to be negative. So instead of multiplying this top one by a positive 3, we're going to multiply it by a negative 3. So times negative 3 times, negative 3 times this. So when we do that, we'll distribute this negative 3. So we will get 21x. Negative 3 times 1y is negative 3y equals 4 times a negative 3, so that's negative 12. And then just rewrite the bottom one, so negative 2x plus 3y equals 5. And we have a positive 3 and a negative 3, so those will eliminate. Okay, let's actually go through one full problem. Okay, so we have negative 4x plus 9y equals 9, and x minus 3y equals negative 6. Let's go ahead. It doesn't really matter which one. Let's eliminate the y's. Okay, so eliminate y. So if I'm going to eliminate the y, we need to multiply this by 3. So multiply this side by 3 and multiply this side by 3. So I'm going to rewrite the top one. So you have negative 4x plus 9y equals 9. And then we have 3x minus 9y, don't forget to distribute the 3, equals negative 18. So we have negative x, these two things cross out, equals 9 minus 18 is negative 9. Divide both sides by a negative 1, and you get x equals 9. Now we have to take this 9 and plug it back into either the top or the bottom equation, and it doesn't matter which one. I'm just going to plug it into the top. So we have negative 4x plus 9y equals 9, and we know that x equals 9, so I'm going to take this 9 and put it in for this x. So we get negative 36. Oh, sorry, I skipped a step. Let me redo that. Negative 4, and then instead of the x, we put a 9, plus 9y equals 9. Distribute the -4, so we get -36 plus 9y equals 9. Put the line down, add 36 to both sides, and we get 9y equals 45. Divide both sides by 9, and you get y equals 5. Oops. So our final coordinate point is 9, 5. So now I have one more thing that I want to talk about. So if I were to go back to these problems that we looked at, on this one, why do you think I picked to multiply the top instead of, or let me re-say that. Why do you think we decided to eliminate the y's instead of the x's? Well, if we wanted to multiply -2 to get 7, it would be a decimal. We would have to multiply this by 3.5. And we don't want to have to multiply it by that. So we try to pick the one that's easiest that would make it multiply by whole numbers.